Welcome to Study Loop.
Okay, this problem describes a situation in which we have an isotopically labeled oxygen on an acetic acid molecule, and we need to convert it into ethyl propanoate, in which we have the oxygen molecule still isotopically labeled in the same position. So here we have my acetic acid, in which we have my isotopically labeled oxygen, and we need to eventually convert it into this compound with an ethyl group coming off of my oxygen. So how do we do this? Well, first of all, we need to add an ethyl group to this oxygen without affecting its position. So I'm going to use a strong base to deprotonate it. So carboxylic acids are pretty acidic, and if we use a strong base such as NaOH, we will have a deprotonation occur. Okay, so this oxygen is still isotopically labeled, and now we can use an alkyl bromide in an SN2 reaction to add my ethyl group. Okay, so now we just have to lengthen this chain somehow. So there are multiple ways to do this. One way that I thought of was if we were to use lithium aluminum hydride, we would reduce our compound into two separate molecules. So again, this is isotopically labeled. We would essentially split my molecule in two and have two different alcohols. One that is isotopically labeled and one that is not. So they're both primary with two carbons, but one of them is isotopically labeled. Okay, so if we can isolate that isotopically labeled alcohol, then we can convert it into my ethyl propanoate by reacting it with a carboxylic acid with the appropriate amount of carbons. So here's my propanoic acid, and if I react it with a small amount of my carboxylic acid in an acid catalyst such as H2SO4, then I will result in